Hi everyone, this is Mohammed Sadiq Aslampur, a PhD student at Monash University and CSIRO Data 61 group. In this presentation, I would present our paper as Serverless Edge Computing Vision and Challenges. First of all, I would love to thank our co-authors who really made a valuable contribution in this work. Let's get started. In this presentation, I would cover the introduction on serverless edge computing, then paradigm on serverless at the edge, and then we would uh, present the opportunities and open issues on serverless at the edge, and finally drawing our conclusions. Uh, Cloud computing. Well, we had the cloud services, which are on-demand resources in terms of virtual machines, as well as the auto-scaling services provided by cloud providers. With on-demand resources, we could reduce the cost and improve the quality of service when we are deploying our applications in cloud. However, there were two main parts missing here. First one, the pure pay-per-use, and the second was the effortless scalability. In terms of pure pay-per-use, well, we used to pay for the resources uh, we are allocating for our application, not the resources we are actually consuming. In terms of the scalability, of course, the cloud providers were providing auto-scaling services to help us. Well, it was not sufficient because most of the autoscalers are general purpose, and making a purpose-built purpose-built autoscaler is not always feasible for developers. Meanwhile, during the recent years, the advances in cloud uh, made us having new technologies in the development side and deployment side. In development, we moved from monolithic applications to service-oriented and microservices, and then we have the function as a service as fast. In deployment, we are moving from heavyweight visualizations to containerizations. And with those technologies, the serverless appeared. I would say serverless attended the reunion between technological advances such as microservices, fast, event-driven programming, containerization, and the idea of pure pay-per-use pricing model aligned with effortless scalability. And fortunately, we have real implementations for serverless, as the pioneer would be the AWS Lambda, and we have also open source solutions like OpenFast and Kubernetes. Serverless in cloud has been successful. I will just refer you to the Berkeley serverless group statement, as they say serverless will dominate the future of cloud computing. That's the serverless. What's the question in this research? Well, serverless uh, has been successful in cloud. On the other hand, we have the IoT, which is a booming area in IT. While IoT demands the computation to be closer to the IoT devices and end users. So the edge computing is intended to bring the computation, storage, and networking closer to the end user, to the IoT, to the end user, to the sensors and actuators. So with edge computing, now we have cloud and edge for IoT, and the serverless is residing in cloud. The main question in this research is that is serverless adaptable to edge computing, and how? Well, at the first glance, we see similarities between serverless features and IoT, requirements. Like serverless is event-driven, IoT is based on sensing actuation, serverless is scaling the application to zero, and IoT devices are energy limited. We see lots of similarities between serverless and edge, so that we can think that bringing the serverless to the edge is really interesting, but it is quite challenging. Well, it is challenging because serverless is not for edge; it's originally designed for cloud. And another evidence is that by 2020, only 10% of serverless use cases are those IoT applications. There has been lots of effort to accomplish the serverless edge computing in both academia and industry. Uh, Given that, I would say the key gap here would be integrating serverless edge computing and IoT applications. And our goal in this project is to fill this gap by expressing our early thoughts on potential opportunities and challenges of accomplishing serverless edge computing. To do so, our methodology is based on expert collaboration and literature review. Yes, we included the expert collaboration because there is not a huge literature on this topic, and this is quite new. So our contribution would be a simplified serverless edge platform, edge paradigm, then a comprehensive list of opportunities and challenges facing serverless edge computing. Let's get started with the serverless edge computing paradigm. We proposed this simplified paradigm uh, in which we have the cloud on the left, we have the edge on the right. IoT devices are connected to the edge, making events, and the events are going to the edge nodes, and edge nodes can run the functions based on the serverless platform, which is distributed over the network from cloud to the uh, edge. If the serverless is in the cloud, it's like the original serverless. If it's in the cloud, in the edge, it is distributed over the network. Let's just follow the process of making an event from the IoT device. If the event is made, it sends the event to edge node. The edge node would run the serverless platform on it. Serverless platform would be in three layers. First layer is the coordination, where the controller would run the scheduler. Scheduler would run the execution engine. The execution engine will would call a function for uh, having the runtime environment for the application. If the function is already run, it can reuse the function instance. Otherwise, it will ask the computing component to provision resources. Again, the computing would look at the monitoring component. If there is enough resource to provision resource for this function, it asks the storage to read the data for the function and provisioning the resource. Otherwise, it would ask the networking component to offload the function to another edge node or maybe to the cloud, depending on the implementation we have. After our serverless edge platform or paradigm, we reached a taxonomy of opportunities and open issues for realizing serverless at the edge. I would start with the opportunities. We have identified 11 opportunities. Let's go to the opportunities one by one. First is pay-per-use, pure pay-per-use model offered by serverless at the edge. Well, we have IoT use cases which will run variable workloads. This is in line with the way pay-per-use model in serverless would work. Another opportunity for serverless at the edge is always on mitigation. Well, uh, in edge, for IoT, we have use cases like smart irrigation systems. which are running on power limited devices and are running periodically applications. So it is in line with serverless, where the serverless is running uh, when we need the function, not always, to save the energy on those power limited devices. The third opportunity is event driven nature of serverless, which is in line with sense, decide, act pattern of IoT applications. Next opportunity is a stateless lifecycle of functions in serverless, while in IoT, certain use cases like road vehicle monitoring systems would repeat running functions, the same function, without having the knowledge of past. So this is in line with the stateless nature of serverless. Next opportunity for serverless at the edge is parallel computations. While with independent functions and tasks, we can run the task independently and parallel. Parallelizing computation is a chance for us to benefit from serverless at the edge. Next opportunity for serverless at the edge is storage isolation. We are decoupling the computation and storage, which is useful when we are going to like have the smart traffic monitoring with bursty workload. In this case, we don't need to shift the whole data or provision the whole data for the application when we are scaling the functions up. The next opportunity is fine-grained auto-scaling provided by serverless. While edge devices are intended to be resource limited, this is while in serverless we don't use the heavyweight virtualization, we use the containers, which is perfect for those resource limited edge devices. We're also recently using the micro VMs, which is another lightweight solution for resource provisioning. Next opportunity is CPU bound applications. When we are specifying the requirements of a function in serverless, we know how much CPU we need. This is in line with the CPU bound IoT applications requirements in IoT. Next opportunity is the bursty workload. Well, we definitely have bursty workloads in uh, IoT, like the traffic or crowd control systems. And this is solved using the effortless and fine-grained scalability of serverless. Another opportunity with serverless is custom-made solutions. Although we have varied IoT applications, in serverless domain, we have lots of open source solutions that they can help us to make custom-made solutions for our specific IoT application. Next opportunity is cloud to edge integration or osmotic computing. Well, sometimes we need data persistent or sometimes we need infinite computation. And for both of them, we need to have a communication with cloud. So in a serverless, a distributed serverless from cloud to edge, we can make it happen. That was the opportunities for bringing serverless to the edge. Now we are going to discuss the open issues facing the serverless in the edge. We have identified 16 open issues for serverless at the edge. The first issue would be the cold start. As long as serverless has the scale to zero and the coldest start, it will not be suitable for latency sensitive IoT applications. So this issue should be solved for certain latency sensitive IoT application before bringing serverless to the edge. In practical, cost efficiency is another issue. While in cloud, most of the users were motivated by the cost efficiency of serverless. But in Edge, we are more concerned about performance in certain use cases because lots of IoT use cases are private and they are not connected to the cloud providers, like a private farm, which is isolated and not connected to the mm, cloud offering serverless solutions. Next issue is continuous workloads and line running applications. Again, research shows that uh, serverless would not be cost efficient for those applications. And if our IT application would have line running application or continuous workload, we should rethink about using the serverless at the edge. Edge AI applications are another application groups that cannot be probably suitable for serverless at the edge. Next is the location and energy agnostic nature of serverless. While serverless in cloud is not probably aware of the location and the energy consumption of devices, while in edge we need to take care of the energy because most of the time we are running functions on edge nodes that are energy limited, like smart farming applications, which are driven by battery operated sensors. Yeah. The next issue is the distributed networking. Well, uh, in uh, edge computing, we need to have peer-to-peer communications. Sometimes we need to share the state, and sometimes we need to offload our task to another edge node in the network, like a vehicular ad hoc network or VANET. Uh, in such circumstances, we need to understand the networking and the distributed network in our IoT application or in our edge node. So this is essential to know that which node we are selecting uh, as the node which is of which we are offloading our task in it. This we didn't have this limitation in cloud. Data shipping architecture, where of course we are specifying the CPU and memory and sometimes both of them to run a function in cloud. But in edge, we need to take care of the storage provisioning also. Next issue would be the brief resource specification in uh, serverless offerings in cloud. For example, in AWS Lambda provided by Amazon, they can run functions for 15 minutes. This is not sometimes sufficient for IT applications which will run data in analytic uh, task. It's not sometimes sufficient. On the other hand, keeping the function warm for 15 minutes is not sometimes a good idea because it may uh, waste the energy for the edge device. Next issue is the reliability and fault tolerance. Well, uh, in cloud, we were not concerned about the failure, but in edge, we need to take care of the uh, containers, the edge nodes, and what do we need to do for failure, especially if our IoT application is like a mission critical IoT application. Next issue is resource inefficiency. Well, serverless is not just a package you can install on your device. It needs Docker, it needs orchestrator, it needs the serverless itself, uh, and we cannot always have the serverless platform with all prerequisites on a single board computer. Recently, we are seeing that lightweight solutions like FastD, which is a lightweight solution for OpenFast, are uh, working in this area to remove these issues. The next issue is security. While in cloud, obviously the service is backed by different layers of firewall, while in edge, devices are exposed. No GPU support is another issue. Next issue is function triggering in cloud, which is different in edge. While in cloud, we used to mostly use the HTTP APIs for function triggering, but in edge, we tend to go for publish subscribe family of communications like MQTT. And fortunately, there are some solutions to fill this gap, like AWS Greengrass and Cube Edge. Another issue in bringing serverless at the edge is that we don't have simulation tools like what we have for cloud. In cloud, we have lots of simulations like the cloud simulator, which is one of the most famous simulators. But we need simulators for serverless at the edge. And the final issue is the vendor locking. We cannot rely on just one serverless provider. That's it. And finally, we would draw our conclusion on the idea that serverless has been successful in cloud. In this research, we evaluate the suitability of uh, uh, serverless for edge computing. We found several opportunities and challenges for bringing serverless at the edge. And as the final thought, I would say that we believe that serverless will bring additional benefits to edge computing if we can overcome these challenges. And once again, I would love to show you our taxonomy, which is showing lots of uh, opportunities and open issues for having the serverless edge computing. Thank you.